We'll continue flux in calculus. Calculation of flux in calculus. Why it is precious? How it comes under commercial calculus. So we have talked about curl in calculus. So curl in calculus and then flux in calculus. They come in commercial calculus. So that is the scenario. Now what is a flux? If I have a vector, if I have a vector and that vector multiplied by the area. If I have a vector multiplied by distance is called line integral. If I have a vector multiplied by area is called surface integral. What is importance of line integral? What is importance of surface integral? So if I have a vector and that vector is force, then line integral results into work done. If I have a vector and consider it is velocity, then surface integral is nothing but flux or volume per second. So if I have a vector meter per second and there is a surface and it piercing the surface and passes through, if I multiply this vector with the area, it gives me meter cube per second. How much is the volume of this vector passes through this surface? If this is water and it has velocity v and it is passing through surface A, then net volume of the water that is passing through this surface is v into A. This is also called surface integral. If velocity of water is v and v has a direction, then it is v vector. If v is algebraic vector where each component of vector is algebra, like x plus yi plus x plus sin yj, then it is vector field. V is velocity turned into vector, then turned into vector field. Now this vector field, when it is passing through an area, net volume that is coming out of the area is vector field into the area. If area is flat, it's alright. Then I have the direction of the area. But this flat area I can turn into something concave, convex area, something that is not flat. If that is the case, then how much is the water that is passing through full this surface? This surface plus this surface, full. How much is what? How much is the water? That water it is passing through this region everywhere, passing through this region. Now passing through full region. That is now vector field V or vector field is denoted by capital F dot, because V can be in this direction also, dot product, now in this direction. Capital F dot dA vector. A vector turns into dA, integral calculus. Earlier it was V dot A vector, V vector dot A vector, capital F vector dot dA vector. Integration over full surface. So this is called surface integral calculating flux. Flux means how much is the volume that is coming out of the surface per second. Per second. Okay, so okay, so if this is the earlier it used to be a flat surface. Then I used a machine, means consider this way. I used a machine and I turned, this is open. So earlier it was a flat, I turned into like this. This is open and this is closed. So earlier it was full flat. I turned into like this. If I place water here, water, and consider these are open. These are, this only boundaries are there. This surface are open. Water will come out from here. Water will come out from here. Similar to water comes out from this circle. Okay. Now this is called surface integral. Capital F vector dot dA vector, integral over full surface. If it is flat, then integral over full surface. If I take this surface in Cartesian coordinate, if it is Cartesian coordinate, then this is x-axis, this is y-axis. Radius is a, then full surface integral is minus a to a x minus a to a y. Okay. If I take in polar coordinate, then 0 to a, 0 to a is the radius variation, and theta to pi. So that is the scenario for the surface integral. We will see flux later. What is the flux calculus? Means later we will see divergence, very big, very big. But anyway, what we have seen in here in the calculation of flux is capital F vector dot dA vector. Capital F vector dot dA vector. Capital F vector I know, but calculation of dA vector is always challenging. If it is flat surface, then perpendicular to this is the area vector. Okay, but if it is not flat and it is like this, then area vector will be again perpendicular to the surface, but everywhere, every moment, the area vector will change. Can you see? So this side area vector will be same, it's a flat, but this side it will change. So what would be the area vector? Algebra plus direction. So algebraic direction, because if you keep changing x and y, the area vector would change. Now question, question that is oops, question that is arising here, that how to calculate area vector. Please watch the previous video, the calculation of area vector. Now we calculated area vector through in Cartesian coordinate. We calculated area vector in polar coordinate. We calculated cylindrical coordinate. We calculated area vector in a spherical coordinate. We were not behind. We calculated area. But there are two ways we calculated area vector. One area vector is, if I take any point, okay, if this is the area and this area, consider this is the origin, this is the, oops, I'm sorry, or consider this is a cylinder and it is kept at the xy plane, and you can see the hole here. So this hole is kept on the center origin. It is kept like this. This is xy plane. Now, if first approach is that you take any small strip here, and that is the area, dA, delta A. We want capital F vector dot dA vector, delta A vector, integral over full surface. So, take a delta A here. Once you take delta A here, then delta A is calculated, and multiply it by unit vector here. Whatever unit vector comes, that becomes delta A vector. Delta A multiplied by unit vector. Delta A multiplied by unit vector. Okay, or delta A into delta A unit vector is delta A vector, which has magnitude as delta A and direction as unit vector. So what in a spherical coordinate system and cylindrical coordinate system, we took delta A, and then we calculated unit vector separately and combined this and called it is delta A vector. But in Cartesian coordinate, where we have x-axis, we have y-axis, and we have z-axis, this is Cartesian coordinate system. If that is the case, and everywhere we thought in our mind that it is a sphere. Okay, so discussion happened thinking in mind that it is a sphere. Thinking in mind that it is a sphere. This is kept at the center. This is centered at the origin. This is kept at the origin. Now at the middle, xy plane is passing, and the center of this ball is kept at the origin. This is centered at origin. Now, if I take Cartesian coordinate, what we have talked? If I take Cartesian coordinate, this is x-axis, this is y-axis, and this is z-axis. They all meet at the center of this ball, that is sphere. Now, if I talk about dA vector, delta A vector, then delta A vector direction would change everywhere. But this vector should be in Cartesian, x, y, z. That is the concept. But here it is difficult to calculate. So idea is if it is centered at the origin, and if I take any point x, y, z here, where z is dependent and x, y is independent. If that is the case, then if I from the center origin, if I take a arrow a vector passing the xyz point, this position vector is xi plus yj plus zk. dp by dx, dp by dy. If position vector is xi plus yj plus zk, dp by dx, how much this position vector is changing? That is I plus d dz by dx k. I k means dp by dx, it varies in xz plane. dp by dy, it varies in yz plane. Okay, somewhere if it is like this, dp by dx, and dp by dy is like this. If dp by dx is like this, in this is xz plane, this is yz plane. If dp by dx is like this and dp by dy is like this, then this is the surface at that moment. If I do cross product of dp by dx and dp by dy, it give me in between area, and direction will be perpendicular to this. So that cross product would anyway give it gives me everything. If I have dp by dx that varies in xz plane, and if I have dp by dy that varies in yz plane, some moment it is like this, then if I do cross product, that comes as this area. If that area comes, then the perpendicular to this area is the direction of this area. That is anyway dp by dx cross dp by dy, in dp by dx cross dp by dy, anyway you will get the through cross product the perpendicular direction. Okay, so this is how we calculated the area. So area vector is not area vector is nothing but dp by dx cross dp by dy. But we landed up in problem that dp by dx is velocity vector. So we got velocity area vector. If I really want area vector, I have to integrate with xy plane. So now area vector is dp by dx cross dp by dy xy plane. In Cartesian it is dx dy. Integration for the full surface. How it will be full surface? It is x and y. xy plane, not xyz. xy integration over dA. So dp by dx cross dp by dy, dA, not a vector. dA, small d, capital A. That is the integration over area xy plane, that is dx dy, and here it is dp by dx cross dp by dy. If that is the case, then we have area plane. Area means xy plane, means there are two independent variable x and y, where x, if I pierce it through, then minus a plus a, minus a plus a. So x is from minus a to plus a, y is from minus a to plus a. If that is the case, then capital F vector dot dp by dx cross product dp by dy bracket close, that is the vector. dot with capital F vector, and then dA xy plane d dx dy. So two ways we calculated dA vector. One vector is like a spherical coordinate system. We calculate the delta area. So delta area in cylindrical coordinate is the arc and height, that is dr theta dz. Delta A area in a spherical coordinate system is vertical arc multiplied by the horizontal arc. So if this is the equatorial plane x-axis, at any height, z height, I make a piercement again. And if I cut it here, then there is another circle with radius r, that is variable, because if I keep cutting at different height, the r will be different. Whereas the radius of this sphere is a, small a. If that is the case, then vertical arc multiplied by horizontal arc at this, if this is the if this is the x-axis, then if I take little height, and here whatever is the arc and whatever is the vertical arc, if I multiply this, then delta area it gives. So if I say that if this is the vertical and radius makes phi angle from the vertical, then this angle is a d phi. Whereas at this position, if there is a circle here, then that arc is, if r is the radius, then r d theta. So r d theta a d phi is the delta A. If that is the case, then what is r d theta? If this is A and this is r and this is vertical component and this is angle phi, then r is A sine phi. So A sine phi d theta, A d phi is the area. What is the, now if I have calculated the area, then what is normal vector at this area? Okay, anyone can do it. Now question arises is, can I do interoperability? That is the question. Why I am talking this much story is, now there are two ways to calculate the dA. One is through cross product, and one is you calculate the delta A and calculate unit vector at that point and multiply. That is also dA vector, delta A vector. Or you do cross product and calculate this. So for cylindrical coordinate system and spherical coordinate system, these are our version. Please support us. So +91 is the India country code, and 94831 94831 This is our telephone number. So please support us. So anyway, so what I am going to talk now, it is extremely precious, and please concentrate here. So now idea is two ways I calculate dA vector, because once you are kind of uh, you are means deft, once you are deft in calculating the dA vector, then your life will be very easy. So two ways we have calculated the dA vector. Can I go for hybridization? So the cylindrical coordinate system, we calculated the area vector and spherical, calculating the delta A and calculating the normal. This is the way in cylindrical coordinate system and spherical coordinate system. In Cartesian coordinate system, we took position vector as xi plus yj plus zk, and dp by dx cross dp by dy. Whatever comes, I integrated over xy plane and integrated over the surface, xy surface, and I got the dA vector. Can I use this cross product for cylindrical coordinate system? That is the story. So in cylindrical, in Cartesian coordinate, what are the variable we have taken? If I take any point in Cartesian coordinate, the coordinate is xi plus x comma y comma z from the origin, that is the position vector. If I place this ball inside a cylinder, cylinder is very small. This is cylinder, and if I place the ball inside the cylinder. Consider this ball is going inside the cylinder. This ball is going inside the cylinder. Now, if that is the case, then if I take any point here on the ball, if I take any point here on the ball from center, if I draw a radius or draw a line, then what is the point? What is the variable in cylindrical coordinate system? R, comma, theta, comma, z. That is the cylindrical coordinate system. Whereas the position vector point in Cartesian coordinate is x, comma, y, comma, z. Then what is the position vector here? R position vector here. Okay. So r theta and z, r theta and z. So it's r component, r vector plus theta component, theta vector plus z component, z vector. R component, r vector, theta comp, because this is not available anywhere. We don't have any particular. I say alpha r vector. R is unit vector along radius direction. Beta theta vector and theta vector and gamma z vector. This is the position vector P. Now dP by dr and dP by theta, considering the z vector as because we are talking about cross product, right? So only the xy plane will come into the picture. So if I this is the xy plane kept on the xy plane, then only r and theta comes into the picture, not the z. So xy plane in cylindrical coordinate system, the base circle is r theta. There it is xy, where z is vertical. Here z is again vertical. Deliberately I have taken it, not a spherical directly. It would be difficult. So now p vector equal to alpha r vector plus beta theta vector plus gamma z vector dp by dr, dp by d theta, the way we did dp by dx and dp by dy. So dp by dr will be alpha, dp by dr will be now this alpha dp by d alpha, that is the r component. So dp by d alpha, or rather, okay, let's go. So dp by d alpha will be r vector and theta vector will go up the way it happened. And now we have d gamma by d alpha, z vector. So now replace it with the z vector with the k vector and here the r vector like this. So dp by d alpha. Now consider dp by dr. dp by dr equal to r vector, r unit vector plus dz by dr k vector. Now dp by d theta, there is nothing theta here. dp by d theta, nothing. So first, I'm sorry, dp by d theta, the first component will go away, and next will be theta vector plus dz by d theta k vector. So the net area calculation is there. It was dp by dx cross dp by dy and d area integral over the full surface area. So dp by dx is dp by dr now, and dp by dy is dp by d theta. If I do cross product, you remember it is minus dz by dx I vector minus dz by dy j vector plus k vector dA. So net flux is capital F dot, and in braces minus dz by dxi minus dz by dyj plus k bracket close dA transform into dx dy. Now here dxy plane will be transformed into r d theta dr, and now dp by dx cross dp by dy transformed into dp by dr cross dp by d theta. So now it will transform as minus dz by dr r vector minus dz by d theta vector plus k vector, because it is z1. Now what is the relationship between z and r? Now if I take a sphere, And then if this is the equatorial xy plane, sphere is centered, consider sphere is centered at the origin. And then if I pierce it at the xy plane at the center, if I take a small z value here, z height, if z height is a, then we reach the top where small a is the radius of the sphere. So if I take, okay, many times I have stated this. So if this is the, if this is x axis, if this is x axis and this is y axis and this is z axis, now if I take a height z, okay, so this is x axis. If I take any height z, or this is smaller, if I take any height z, this is a, the radius of the sphere. If height z is there, then there is a radius small r here. This radius will keep varying. If I go down little, then radius is like this. This much is the height. If we go up, the radius is this much only. So this radius is, this height is nothing but a square minus r square. So we will change it. So dz by dr, r vector, minus dz by dr, r vector, minus dz by d theta, theta vector, plus k vector, dA, that is the net dA vector. So z is the square root of a square minus r square, dA square root of a square minus r square by dr. That will transform into, I believe, minus r divided by square root of a square minus r square plus r vector, minus r divided by square root of a square minus r square, r vector, minus dz by d theta. There is nothing theta there, so that is 0, plus k vector. And this is impossible that you will get anywhere. And then r d theta dr, that is the dA xy plane, r d theta dr, r d theta dr. Okay, idea is that can I prove that if I take cross product, and if I calculate dA, if I take cross product, if I calculate dA vector through cross product, and if I calculate dA vector through taking the dA in cylinder somewhere here and multiplying it by unit vector, are they same? This is $1 billion proof. Okay, so are they really same? Now r d theta dr, what is the actual the dA vector in cylindrical coordinate system? It is cos theta I plus sin theta j r d theta dz. Here we have r d theta dr, and here minus r divided by a square minus r square, r vector, plus k vector, r d theta dr. Now now z equal to a square root of a square minus r square, z equal to square root of a square minus r square. So dz equal to minus r by square root of a square minus r square dr. So dr equal to dz into square root of a square minus r square divided by minus r. Now I can replace dr with dz into square root of a square minus r square, a square minus r square divided by minus r. Okay. Now the full terminology has led to dz by dr is minus r by square root of a square minus r square, r vector, plus k vector, and then r d theta and square root a square minus r square divided by minus r dz. Okay. Now by dz. So now proceed and multiply it here. Now proceed and multiply it here. Keep the r d theta together, r d theta dz together, r d theta dz together, and we have extra now, that is extra now, that is the square root of a square minus r square divided by minus r. Multiply whatever you have on left side. So here it will become now, if you multiply, then it will become minus r vector. Full term what you had with r vector, that will be cleaned by this person. So it will result into minus r vector plus k vector if you multiply here, then it will be a square root of a square minus r square divided by minus r k vector. Now since it is cylindrical coordinate system, we are talking only about the boundary area, not the kind of. So r in the boundary area is constant, and it is equal to a. It is equal to a. It is equal to a. If that is the case, then all r I can replace with a. If that is the case, then k vector will go away. So it is now minus r vector, r d theta will become a d theta, a d theta dz, because the radius is constant in cylinder, it's not a sphere. So now the integration turned into r vector, r vector, r vector a d theta dz. R vector, r unit vector. R vector means r unit vector. So r vector is r cos theta I plus r sin theta j. R unit vector is cos theta I plus sin theta j. So finally, if I take it through cross product also, the dA vector turned into cos theta I plus sin theta j. Minus is coming, that we will see. Cos theta I plus sin theta j a d theta dz. So the way we took the cross, if I consider cylindrical coordinate system, dA vector is perfect, then cross product is perfect. If I think cross product is perfect, then dA vector, the way cylindrical and spherical coordinate system, we did a proceeding, that is also perfect. So it's perfect. So we can achieve both ways. What is homework? Homework is the way we proceeded through Cartesian coordinate, the way we proceeded through cross product Cartesian coordinate, where we integrated with the dxy plane. Can I proceed this? Can I proceed this with the same fundamental in a spherical coordinate system and prove it that the dA vector is sine phi cos theta I plus sine phi sin theta j plus cos phi k, and then there it is a sine phi d theta, a sine phi d theta, a d phi. This is the d area vector. So start from the cross product and try to achieve this. Start from cross product and try to achieve this through the kind of, through the dp by dx cross product dp by dy that we calculated separately for the spherical coordinate. So begin from the cross product dp by dx, dp by dy, and achieve what we considered in the dA vector, the spherical coordinate. dp by dx cross dp by dy, we achieved in cylindrical coordinate system. Now try reverse way. If I have dA vector the way we calculated in the cylindrical and spherical coordinate system, I multiplied with the unit vector, and it came as dA vector. Can we try reverse way and calculate, get the minus dz by dxi minus dz by dyj plus k without cross product, dx dy. Okay, so from cross product we are verifying that other dA vector was correct, and from dA vector calculation try verify cross product in Cartesian coordinate is perfect. Okay, so support us. Our number is +91 India country code 94831606110. So we will proceed in this, and we will see example also. Consider one hemisphere. Consider one hemisphere. So if this is a sphere centered at the origin, if I chop it at the center, the top part is hemisphere. There is a vector field, that is vector field equation is zk. Zk. Then for the top hemisphere, what would be the flux? So capital F vector dot in a spherical coordinate, capital F vector dot. Now sin phi cos theta I plus sin phi sin theta j plus cos phi k, and then sin phi a sin phi d theta, a sin phi d theta, yes, I'm sorry, a sin phi d theta, a d phi. So if I do this, then I'll calculate the flux integral over where a is 0 to means radius. I mean theta and phi as variable. So if I talk about the top hemisphere, theta is full to 360 degree, where phi is from 0 to 90 degree. So 0 to 90 degree is phi, theta is 0 to 2 pi, and then zk dot sin phi cos theta I gone because k is there, and sin phi sin theta j gone, only cos phi k will come. So z cos phi, and then a sin phi d theta, a d phi. So sin phi a sin phi, a square sin phi, and here it is cos phi. So a square sin phi cos phi. Z, what is z? What is z? Z is a cos phi is the z. So a again, so a to the power 3 cos square sin phi, cos square phi sin phi, and then d phi d theta, cos square phi sin phi d phi d theta. AQ is outside, and then now integration phi 0 to pi by 2 and theta 0 to 2 pi. Now you calculate and we will see it, and you will get now flux of any vector field zk, any vector field zk in top hemisphere. So very interesting. dA vector, if you crack it, then you crack everything. So that we will see.